In this video, we'll discuss about merge sort. Now remember, merge sort algorithm is an example of divide and conquer algorithm. It takes advantage of two facts. First one, small lists are easier to sort than a large list. And number two, it's easier to merge two ordered lists than two unordered lists. What does it mean? So, simply, a merge sort algorithm has two parts. First one is splitting items and then merging them together. In the splitting part, it is continuously splitting a list in half until all the elements are in a list by themselves. That's the splitting part. Then, after splitting them individually, we merge them together. How we merge them? We merge them one pair at a time. We merge them one pair at a time into new ordered list, and we repeat it until all the lists have been merged into one ordered list, right? So here is an animation. I'm going to wait for this animation to come back to the beginning of the splitting part. At this moment, it is actually merging, as you see, checking left and right, compare them together, and then merging them, putting them in right order. So this animation gonna go back to the beginning, right? As you can see, it is comparing left item to right item and then put together, right? In ordered list. Now it's gonna go back again and we're gonna sit in the beginning. So this is the list initially, then it just split it half and half and half until all of the items are in their individual list. Then we stitch them together, merge them together pair by pair. Before we merge them, we just checking, compare the value and order them. As you see 8 and 7, so we need to order them properly to import the next pair. So we don't need, it's already ordered, we just put them together. Then left and right pair, checking left element with the right element, order them if we need to, and then we continue with the next two pairs as well. 7 and 2, compare them, order them. 7 and 4, 4 comes first, 7 and then 8. We have left and right still, so we're checking left item with the right item, pair by pair, and then order them. The one is smaller comes first. Then compare again, the one is smaller come first. Compare the pair again, the one is smaller come first, and the rest comes normally. So that's basically it. Split it and merge it. Split them until all of them are individual, and then you merge them pair by pair. Each time you're merging them, make sure you check, you compare them, and then you put the smaller one first. Okay? Here is another example, right? So this is this is our list. We merge them, we just break them half in another word. Then we have two part left and right. Then we break them half again. We break them half again. Remember, there is a situation there might be one individual element, and that's fine. Okay, we mark them later on. Now again, we break them until all of them are in their individual list. Remember, in the exam, you need to show these steps clearly. Okay, without showing these steps, you cannot expect to get full marks. So clearly label it, which is your splitting item part and which is your merging item part, right? Okay. After splitting items, then we're going to merging items, right? We're just comparing pair by pair, and we just, if you need to put them order, put them order. So for example, 43 and 21, 21 comes first, 43 goes next. Same way here and here, and here just individual one. It's gonna compare in these steps, right? So we are comparing left with comparing right, and then we check pair by pair, and then we decide which one need to come first, which one go next, right? And by this way, we are going to end up with a ordered list. right? So the reason I'm just showing you different examples, here is another one. The reason I'm explaining more and just asking you to pay more attention, because with this knowledge, this understanding, we are going to write a Python code for this merge sort algorithm, right? Remember, if you are a GCSE students, you do not need to write your own merge sort file code, but it is expected that you understand how it works. It is expected that if you see a question, if you see an algorithm, you understand, okay, this is merge sort happening there. Okay, because over the years I have seen some questions come with merge sort algorithms, and they ask you some questions based on that algorithms. So if you don't understand that this is merge sort happening there, of course you cannot answer any questions. So you should pay attention, at least try to understand how this code is happening. Is it really merging and splitting parties there? How it is comparing and sorting this out? And of course, if you are A-level students, you need to know this by heart. You should be able to write your own merge sort code, right? Before we jump in there, this is the last example I'm going to show you. So again, this time it's not number, but again, the same way. You have full list, you break it half, then break it half again, break it half in all of those until you have a individual list. Okay, all of them are in the individual. Here we have this splitting part done. Now we will merge them together. How we merge? We check left part and right part, and then compare them, and then we put them order. Left, right, compare them, put them order. Left, right, compare and put them order. Left, right, compare and put them order. Then again we have this left little list, right little list. We are comparing first element to first element, and then the next element to next element. So for example, F comparing with A should come first, so A comes down. So we have F and P left here, A left here. So we're comparing, still F is here, so we're comparing F with L, and we know that F should come first. So A gone, F gone. Next items are P and L, and we know the L should come first and then P. Same way, D need to be compared with H. Of course, D comes first. Then we have T in the list. T compared with H comes first. Then we have T and K there. And of course, K needs to come first and T. Same thing again, we have left little list, right little list. The idea is you to compare pair by pair. You're going to compare the first one with the first one. First element with the first element first. So A with D, A goes down, right? But now we have F. F with D, D comes here. Then F with H, F comes first. Then L with H comes first. Then L with K comes first. Then L with T, L comes first. Then P with T, P comes first. And of course we have T left, so T comes next. That's basically merge sort is. Now I hope to understand that how we are stitching them together, because this is the one of the thing very hard to understand when we see that code, right? Now let's jump in and write a Python code together. Okay, let's write the Python code. So this is our initial list, and just randomly add some number there. Okay, make it a bit bigger so it's easier to explain sometimes, you know. Okay, so this is our initial list. Now I'm going to write a function. So def, let me give the name merge sort. It is taking the parameter. The parameter is the list itself. All right. Now let's find the length of the list. Right? We need to know the midpoint so we can break it down. So mid equals, I can say n. and we are expecting a integer value. So I done n and then find the integer division for that, right? Now after that, so now it is indicating the middle point somewhere here. So we have two part. One is left part and another gonna be right part. Okay. Now I want to put all of the left items in the list called left, right? So we just simply do that, right? I'm just explaining a little bit how it's happening here, but hopefully you understand this. Uh, what's happening here is it is simply saying this is wrong. Simply saying take this list and then start from the beginning, the stop before the mid, put them all in a list. Same way, start from the middle and go all the way down there, right? To prove it, how actually we are getting here, let's find this left. I want to see this left and right. Okay, this is not part of, this shouldn't be part of our marsuit, but I just want to give you a quick glance actually what's happening here. Okay, so far. So marsuit I'm giving array. If I run this code, as you can see, it is splitted here. So all of those goes in the array, left array, and then the rest, I mean from middle to the end, come in the right. Okay, so it is working right. I don't need this part, so leave this one now. Right, so this is basically just the one split. But remember, Marshall works, it just keep repeating. It just break it down half again, then break it down half again, right? That's how it works. Keep half, then again half, and then again half, until all of them become individuals. So we are doing something very interesting here. We are using a mechanism called recursive function, right? Another word, recursion, all right? What it does really is this. Let me write it down first, then I'll explain a little bit. So I'm calling the merge sort itself. So what is happening as you see, this name is familiar to, isn't it? See, same function, merge sort. But instead of calling it upon the array itself, this time I'm calling to the left. Left is this array. This little array is left. I'm calling it to the right part, this part of it. Why I'm calling it? So it's gonna keep repeating this part. It just find the middle value of left, then it split it in left and right. It's gonna find the middle value of right and keep splitting left and right. Right? We call it recursion. We call this a recursive function because recursive means a function when it is calling itself and keep doing the work, right? Same thing over and over, calling itself, doing the same thing over and over. I have a video about this recursion, so you can watch that for more explanation. For here, you just simply remember that as we need to split it over and over again and again until all of them are individual, we just need to keep repeating this part. And that's what this recursive function is doing here. Just calling itself, but this time it is calling up on our left, calling up on our right, and we are just have a new left array and right array. We're doing it. Now, I just may simplified it really because we're going to write some more code after that because it is not only the merging part, we need to split it together. But to keep it really, really simple, I just oversimplified it saying that we just need to keep repeating, splitting it and until all of them are split. Question is, how long we're gonna split it? There should be a time where we need to stop, isn't it? And that's the reason we need to write a base case. We need to give a base condition if in any moment n becomes smaller than or equals to 1. Okay, we say do not do any more splitting, do not run this recursive function anymore. Stop, return that, right? So without this, your code actually give you error because this code just keep repeating it, keep doing it. It doesn't know when to stop. And here is the stopping condition saying if the length of the array, which is n, is smaller or greater than 1, that means when it hit one individual item, it stops. So when it hit 90, and then another list is 8, another list minus 3, all of them will become individual. We say okay, stop, return that value now as an array, right? So that helps us with splitting part. Now let's merge. So splitting part done. Now let's merge. Before we merge, I just want to give it a bit easier way. Let's create an empty list. My idea is I'm going to check my left and right, and then I'm going to put them one by one, which one is smaller, right? I have left array, I have right array. I'm going to compare the first element to the right element, and which one is smaller, I'm going to append in this empty list. That's my idea, right? So I have created an empty list, and I'm going to create two variables, L equals 0 and R equals 0. What they're doing, L is indicating index for this array, and R is indicating for this array. So this way I can keep track of the element. Then I have a condition to write. I said while L smaller than the length of left array and R is smaller than the length of right array. As long as this condition is true, means as long as I have some item left, it's not 0, it's more than 1. As long as this is true for left side and right side, I want it to compare left element and right element. How to compare? Selection. So if left array index start from L, because L start from 0, is checking now comparing them. Right array, and the name of the index from the right array is R. So think a second, if the left element of the left array is smaller than right array, which element should come as in the first in the ordered list? Of course, left array. That means I need to take this element, add it in my list, the result empty list, right? So result dot appending what? Left array, and the index is L. And don't forget, if you take the first L, your next L should pointing to the next element. So L plus equals 1, or another word L equals L plus 1. So this is the case when left array is smaller. But what happens is opposite true. That means if the right array is smaller, then of course I need to take the right array. Okay, the index is R, and in that case also I need to increment it, so it's gonna look at pointing at the next item. We're nearly done. So again, before you write the next, what's happening, we are checking a condition first. As long as I have some value left here more than 0, and some value elements left here more than 0, if this is the case, I'm going to compare them. Compare this with this. Just for an example, right? And then I'm saying, okay, if the left array, it is smaller item in there, you need to take this, append it in my empty list result. When one is gone, of course my L needs to point to the next item, and that is the reason if you take the left array, make sure you write L plus 1 plus equals 1. That means it should increment this value to the next element. Same way, if we are taking the right first element from the right, make sure we do this r plus 1 equals 1 just to point our r to the next element. This way, one gone, r pointed to the next and next and next, right? Now, our main job is done. But remember, sometimes we saw that what happens, like this example, right? It has how many elements here? 1, 2, 3, 4, 5. Here, 1, 2, 3, 4, 5, and 6 elements. That means in some occasions you see all of them we are comparing done, but there is one left. In another situation might be some one left here, right? In those situations we cannot leave them alone, can we? So for that reason, if there is anything left, we need to write a code for that when we're saying while L is still smaller than left array, that means it's something left basically. After comparing all of those, you just simply append that because this all of them are already ordered. That means it should be comes automatically. So left array and the index is L, and of course if you're taking that value means you need to increment the L value. We need to do the same for right array. So if in any case R is still smaller than right array, that means still there are some value left in there. We just take it and append it in the result, right? So right IH, and the index is R, and of course you need to increment the R value. Okay, that's basically it. And then of course you need to write return when everything is done. Now return me my R. Now we are not returning R, we have newly sorted one, so yes, return the result. Okay, because all of the sorted elements are stick in there in ordered list. And at last we just need to print our merge sort, and the parameter is r, that value is already done the beginning, right? So that's basically it. I hope I didn't make any mistake somewhere. And it's printing twice, most probably I printed twice somewhere. Yeah, it's here. I called it and printed twice. All right, so run it. As we see, it's nicely sorted from -10, -3 to 8, and all the way down there nicely. So it is a long program, really, and especially in this part, it is a little bit mechanism, and hopefully you'll see my recursive function video. Hopefully it will make more sense to you, but here I just explain and oversimplify something for you, so at least you can write this code. Okay, right, hopefully it helps. Write it down several times. Please look for all of this scope, right? Indentation, do it carefully, and then write it several times. Hopefully you'll understand this code. That's all for today. Thanks so much.